Good afternoon, everybody, and welcome. Today's session is all about app performance. My name is Joel Newman, and I'm a product specialist on the Google Play business development team. In that capacity, I've worked with Android developers of all shapes and sizes, helping them to leverage the tools available in the Google Play console to build successful app businesses. Now, I'm going to kick things off with a quick reminder of just how important performance is to app business success, and why Android Vitals can be a critical tool in helping you improve your performance. Then my colleague Fergus, product manager for Android Vitals, will join me on stage to talk about some of the ways we're enhancing the platform to make it easier to understand and action your performance information. Then my colleague Wojtek from our developer relations team will come on stage for a technical deep dive to talk through some of the common causes of performance issues and how to address them. Finally, we'll wrap things up by talking about some of the resources available within the Play console itself and beyond to improve your performance. And if we have time, we'll try to do a brief Q&A. Now, first, I think it's important to remind ourselves of why performance is important. Now, I think this is intuitive, right? Like, we as users, nobody wants to deal with an app that crashes frequently or freezes or is janky. But at Google Play, we have data that drives home just how important performance is. We did an analysis of all the reviews on the Google Play Store over the past year and found that when leaving a one-star review, over 40% of the time, users cited negative performance indicators like stability and bugs. In fact, this was the #1 cited issue within one-star reviews. Now, on the flip side, when leaving 5-star reviews, over 70% of users mentioned positive performance indicators, things like speed, design, and usability. Now, why is this important? Well, not only are ratings and reviews a direct and leading indicator of customer satisfaction, and not only do ratings figure heavily in the Play Store search algorithm, but ratings and reviews correlate strongly with downstream business KPIs, things like engagement, retention, and monetization. A great example of how that performance can impact key business KPIs, it comes from this study. We did an analysis of all of the games in Google Play, and we compared those with the lowest crash rate versus those with the highest crash rate. And we found apps with the lower crash rate saw almost 2.5 minutes more of gameplay per day. And this was even a bigger trend when we looked at ANRs, which are more frequently looked over relative to crash rate. We found that users spent almost 3 minutes more per day in the more stable apps. Now, this may not sound like a ton of time, but when you look at this over a yearly basis, this would translate into 18 hours of additional gameplay per user for games that are played on a daily basis. Now, another reason why performance is incredibly important is that it's becoming an increasingly important signal within Google Play for both search and discovery. As Google Play is committed to surfacing only the highest content to our users, we're increasingly taking into account performance signals, particularly those related to stability and battery consumption in both our Play Store search algorithm as well as our algorithmically generated recommendations. And in addition to that, performance signals factor heavily into our decisions around our editorially curated content. This includes our featured new and updated apps collection, as well as Editor's Choice and coveted Google Play Awards and Android Excellence. If you want your app business to succeed, your app needs to be discovered. And technical performance is an increasing part of that discovery within the Play Store. Now, it's exactly because of that increasing importance of technical performance that we launched Android Vitals last year. Android Vitals is an initiative by Google to improve the stability and performance of Android devices by surfacing to the developers in an easily understandable and readily accessible way the most important performance metrics in battery, stability, and rendering. This comes from over 100 million users who have opted in to share the data with Google and with you, our developer partners. And since the program's launch a year ago, it's been an incredible success. We have over 100,000 developers, including some of the biggest names on the Android platform, regularly engaging with the Vitals console to understand their performance issue and create fixes. Now, it's because of this incredible engagement that we've seen some really nice gains at an ecosystem level. When we compared reviews in the Play Store today versus a year ago before we launched Vitals, we see a really nice uptick in those people leaving 5-star reviews talking about things like speed, design, and usability. But perhaps more importantly, when we look at people leaving 1-star reviews, we've seen an almost 20% decrease in the number of people talking about things like stability and bugs and battery consumption. And that's only possible because of the incredible work that you have done as a developer community to up the quality of Android apps. And for those of you who are new to the platform, it's really important that you keep pace with the rest of the developer community who is helping us move in a positive performance direction. Now, I think with these gains at an ecosystem level are interesting. You might wonder as an individual developer, yeah, but how does that really matter to me? Well, I want to showcase a couple of examples of where individual developers have seen incredible gains because of Android Vitals. One of my favorite case studies is Starbucks. Now, Starbucks is obviously an incredibly popular app. They have over 15 million downloads on the Google Play Store. They started using Android Vitals in December, admittedly several months after the launch of the program. Now, when they started using Android Vitals, they were alerted to ANR issues that were not even on their radar. And they were able to use the reporting in the console to identify common underlying causes for the ANRs that were caused by a third-party library. They removed that third-party library and saw a 70% reduction in ANR rate within a week. Now, they saw a similar and actually even better experience with crash rate. Because Android Vitals is a platform-level tool, it's able to detect crashes that were not detected by Starbucks' third-party crash SDK, because these crashes were happening at app start before Starbucks' third-party crash SDK had even initiated. Using the Vitals reporting, they were able to identify an underlying cause, push a fix, and they saw an 85% reduction in crash rate within a week. These are impressive stats. Now, it's worth calling out that Vitals, and this is a common misconception, is not just for apps. It's equally relevant for games. A great example comes from Kaloo, developers of the super popular Subway Surfers app, which was actually the first game to pass the 1 billion install mark on Google Play. When Subway Surfers started using Android Vitals, they discovered a sudden increase in ANR rate, used the reports to identify a cause and pushed a fix, and saw a reduction of their ANR rate from 2% to below 0.1%, a 95% reduction. But I think what's worth calling out here is what we found afterwards. So we did an analysis at Google Play of what was the change of engagement with the app before and after the fix. And we saw really substantive gains in both daily active users and in sessions per users across the board. Now, these are just two examples of developers who have been able to leverage the platform to see really significant gains, both at a performance and a business level. Now I'm going to invite up Fergus, product manager for Vitals, who's going to talk about some of the ways that we're enhancing the platform to make it even more powerful for developers.
Great job. Hey, everyone. I'm Fergus Hurley, product manager for Android Vitals. It's been incredible to see the improvements that app developers like yourselves have made over the past year as a result of using the tools that we've made available. It's also been incredible to get all the feedback from you as to how we could improve Android Vitals. And I'm really excited to show you the new features we have available today as a result of your feedback. So thank you so much. Last year, when we announced Android Vitals, as Joel mentioned, we launched 3 performance areas: battery, stability, and rendering. Today, we're announcing 2 new areas: startup time and permissions. Battery is probably the most important performance area to focus on. This is where you should not unnecessarily use the CPU or the radios on the device, which drains users' batteries, which means they can't use your app as long. Stability is all about building a robust and reliable application so that users are using your application without freezes or crashes. And rendering is all about building a fast and responsive application that's silky smooth and doesn't lag or stall on users. With startup time, we're enabling you to be able to provide a quick launching application to your users, no matter what state your app has been in. There's 3 different metrics we have here, and I'm going to go through each one. So first, we have slow cold start. Slow here is defined as 5 seconds or more. And cold start is when your app has not been launched in a while and is going from activity launched to activity running, and the app is not in memory. Slow warm start is where it takes 2 seconds or more for your app to go from activity launched to activity running, but your app is in memory. Final startup time metric we have is slow hot start. This is where your app goes from on restart to activity running, and it takes longer than 1.5 seconds. This is where your app and your activity is in memory. Another new performance area we have is permissions. This is where we want to help you be able to only request permissions that users think are required for the core value of your application to be provided to them. And if they don't think so, then provide them justification why you think they should actually provide that information. When we ask users, what are the reasons that you deny permissions for applications, what we find is that the vast majority of them just think that the app doesn't need those permissions. So really providing a justification is critical for you to get users to be able to give you the permission that you need to be able to offer the best functionality possible in your application. In the details view for permissions, we provide a breakdown by permission group. So maybe one of your permissions users think your app does need, and you get a high percentage of acceptance for that one. And then another one users don't think you need, and you get a high denial rate for that one. And maybe you don't need that permission in the first place, so maybe you should rethink it, or maybe you just need to explain to users why your app does need that permission. We have many other breakdowns across the Vitals product. For most Vitals, we break it down by app version, by device, and by Android version. For wake locks and wake ups, we provide by tag. For ANRs, we provide by ANR type and ANR name. We also provide the clusters view for grouping your ANRs together so you can be able to see which ones are similar and be able to debug those clusters. For crashes, we also provide clusters. When I've been building apps at Google and prior to Google, one of the things I struggled with the most was being able to understand how do I compare with other apps that offer similar functionality. Who else has struggled with understanding if their app is performing well compared to other apps? OK, lots of people share the same struggle as I've had. We are now going to announce category-level benchmarks in the Play console. This enables you to be able to see, OK, for start time, you can see here that board games are much faster at starting than racing games. And we also provide the 25th, 50th, and 75th percentile breakdown for each of the category-level benchmarks. We'll default to the category that you list yourself in the store, but you can select any other category that you want to be able to compare yourself with in case you don't think that your app is as related to that category. On the details page for every vial, we show you this breakdown for the category benchmark, and then you can be able to also see what exact percentage you are relative to the other apps in that category. On the redesigned Android Vitals overview page, we show you each of the metrics in the performance area. We show you what was your percentage of users impacted in the last 30 days, what was the percentage of users impacted in the previous 30 days, and we show you the benchmark comparison. This enables you to be able to quickly see, OK, which one of these performance areas should I actually look into, and which specific metric might require more attention. And so you can see here the last one on the list, you're in the bottom 12%, so that's probably one you want to investigate. The Weather Channel has been an early access partner for these features that we're showing today for the past couple of weeks. And one of the pieces of feedback that they've had is that it's been really great for them to be able to use category-level benchmarks to make the case within their company as to why they should invest in performance, because they can show how they stack up versus competing apps. I hope you're able to use similar data to be able to make the case within your company. If you want to learn more about benchmarks in the Play console, we have a session on tomorrow at 9:30 a.m. Although all Android Vitals should be viewed as ways to be able to enhance the experience of your application. Some vitals are more important to offering the best user experience possible. And so that's why we're putting this feature at the top of the Android Vitals overview page, which is core vitals. These are the vitals that you should pay most attention to. These are the ones that will impact your promotability and ranking in the store, along with many other signals. But you should really pay attention to these signals. You'll see the list of the vitals. Here we have the initial 4, so stuck partial wake locks, where you hold a wake lock for over an hour in the background. Excessive wake ups, where you have 10 wake ups happening per hour. ANR rate, where you have a user experience the app not responding for 5 seconds or more in a day. And a crash rate, where they have 1 crash in a day. If you're in the bottom 25% for any of these these core vitals, then you'll be flagged as having a bad behavior. This is where you'll see a tile at the top of the core vitals section to alert you. And when you click on that tile, you'll be able to go into the details view and see which specific APK is exhibiting that bad behavior. And we provide you the information to help you debug that issue. One other major request that we've had over the past year is to get alerted when there is an issue that's introduced with their vitals. And so we're really happy to announce anomaly detection. So this is where you'll get flagged with an alert at the top of your Android Vitals section, are the ANR and crash clusters, to let you know what is the issue that you have. And you can click on that tile and be able to go in and see details. You can also be able to sign up to get email alerts where when one of these anomalies is detected. And when you get one of those emails, there's a link directly to the issue, so you can be able to investigate, OK, when did this issue occur, and for how long did it happen? The Big Fish Games team that have built many games that have reached over 10 million installs have found great results with using these tools by being an early access partner for these features over the past couple of months. And they've reduced their crash rate by 45% for one of their top games. I'm now going to hand over to Wojtek to talk about how you can debug and improve your specific core vitals issues.
Thank you, Fergus. So hi, everyone. My name is Wojtek. I work on the developer relations team, and I work closely with the Android teams at Google to help you developers build better apps. And today I want to talk about how you can fix some of these core vitals that Fergus mentioned in your apps, in your code. And first, I want to start with the stability. And let's talk a little bit about ANRs. So we keep saying this acronym, right, ANRs, but what are they really? So ANRs, in other words, application not responding events. Now, this happens whenever in your app some long-running operation blocks your main thread. Now, the main thread is responsible for things like responding to user events, such as taps, or redrawing the UI for every frame. So if we block it, if the main thread cannot do that in a timely manner, the app will just seem frozen. And then after a few seconds, the system will notice that and will pop up this annoying dialog that lets the user actually close the app. And as developers, we really don't want that to happen. So what are some common causes of ANRs? Like, what kind of operations can block our main thread? Well, probably the most common ones are network and disk operations, also called as I/O. Now, networks are congested, remote servers are slow, so can be your flash drives, or the file system can be busy with other operations. And so, as developers, we should never, never do network or disk operations on the main thread. But you know, I just prepared 2 code examples to show you that it's not always easy to do the right thing. Even though you all probably agree with me, we can still make mistakes. So here, for example, in my activity on create, I decided, well, I'm just going to prepare this shared preferences object to use later. I'm just going to create it and not do anything with it right now. And then somewhere else in my app, probably on a background thread, I will actually get some information like read an integer or a string or whatever. And I thought, OK, that's good. I will not be doing disk operations on the main thread. What I didn't realize, though, is that the implementation of shared preferences on Android actually eagerly reads data from disk the moment you create them. So that's actually the line of code that does disk access. So I was wrong. It's not always obvious. And let me show you another, even trickier example. So here, I'm doing some hypothetical network operations in my app. So let's say I want to check if my intent contains some kind of URL. So I'm comparing the two. And then I say, I want to open connection to that URL. I'm going to save the headers to some variable for later use. And then I actually open an input stream. And finally, in the end, I am reading bytes from the network. So this is a pretty complicated API, to be honest. And how am I, as a developer, supposed to know if that first line, open connection, creates the network request and actually blocks my thread? Or is it the last one, where I actually request to read bytes of data to actually read them into my application? Or is it something else? And, well, it's not obvious. Actually, in this example, this line of code will perform a network operation. Like, the first time I'm trying to access headers, only then will the connection be opened and the first bytes will be read. And so as a developer, again, I failed. I didn't know which operation does the network access. But fun fact, on an even older Android version, this line, just checking if two URLs are equal, can perform network operations. OK, so why am I showing you all this? Because I want to convince you that as developers, we cannot know everything. And you will use libraries that you're not familiar with, or other APIs. And that's why I suggest you use strict mode for your debug builds while you develop your apps. Now, strict mode is an API that existed on Android for a long time. And it's pretty easy to set up. You just set a thread policy in your application on create or in your activity on create. And you tell strict mode, I want you to detect all disk operations in my application on this thread. And I also want you to detect network operations. And then you tell strict mode what you want the result to be. So first of all, of course, we want to see it in logs, so we can debug it later. But logs are easy to miss. Like, logcat can be noisy sometimes. So for my debug builds, I'm also going to go and say penalty death, which will actually crash my app whenever I do the wrong thing and access network or disk on the main thread. Now, like I said, you don't want to do any of that in your production release builds because you don't want your user's app to crash. OK, so now I go back and run my code that I just showed you and look at my logs because my app obviously crashed. And I see the exact cause, and I can go and debug that. So I can see there was a strict mode disk read violation, and I can see in the stack trace the culprit is, it's the get default shared preferences call that I did in my activity on create. So great. This lets me actually go and fix that. OK, so we covered network and disk operations and how to cache them. Sometimes you don't even need to hit remote servers or disk to cause a long-running operation. All it takes is literally just calculating something for a long time, doing a very long loop and something like that. So here in this example, this is a sample Sudoku game. And how it works is when the user opens the app, the Sudoku board is actually generated in memory. It's not read from disk. It's not pulled down from a server somewhere. There's actually a pretty long, complex calculation happening to show that first board to the user so they can play it. So it's this one call, generate board. And as you can see on a slow device, this could cause an ANR because I'm doing that on the main thread. So first of all, how am I supposed to know as a developer that this call, generate board, can be long? Well, I really suggest that you use Android Profiler regularly if you ever suspect there's any performance problem in your app. So here, for example, I took a CPU trace of the method generate board in the Android Profiler, and I can immediately see that it's a complex recursive call that takes a long, long time to finish. And so now I know I should not be running it on the main thread. Oh, and by the way, there's a new thing in the Android Profiler that we just released in the canary today. Now you can debug and profile your app startup time. So that's pretty handy. OK, so going back to our problem with our generate board call, what can I do with it? So strict mode has this method of telling it that a call can be slow. So here, as a developer, as the person who created this Sudoku algorithm, I will tell strict mode to note the slow call. And now whoever else touches my code and is using it and uses strict mode as well, if they also set the detect custom slow calls thread policy, again, they will get notified. Their app will crash, they will get the log, and they will know to never call that generate board method on the main thread. All right, so what are some other causes of ANRs? Be careful if you're doing any kind of inter-process communication and expect a result. Don't do it synchronously on the main thread. If you're calling some other application, if that call is leaving your process, you basically don't control what happens on the other side. IPC goes through layers of the operating system. The other process can access network and disk to service your request. So just remember to do it on the background thread. The next thing is multi-threaded programming. And that's a really, really difficult topic. Like, we could have a whole other session about this. But if you ever find yourselves touching low-level primitives such as locks and synchronization, eventually there's a high chance you'll create a deadlock in your application or hit some other problem that blocks your main thread. And these are very tricky to debug. However, Android Vitals does give you some information that will help you debug these kinds of problems. So if you open any ANR in the Vitals console, we actually provide you with the trace files pulled from the devices that suffered from these ANRs. So you can look at thread states and see if they were blocked, waiting on any resource to become available. And we even highlight the problems that we think might be happening in this trace. OK, and then the last thing I want to mention is, as a cause of ANRs, is slow broadcast receiver handling. Now, not every developer realizes that if you set a broadcast receiver in your Android manifest, and then it gets called, that the onReceive method actually happens on the main thread. And you're not supposed to perform any long-running operations in it. And there's a timeout, about 10 seconds, that the system will allow this method to run, and then it will kill your process. And so, sometimes, though, whenever you're using a broadcast receiver, maybe to show a notification to the user, maybe you still need a little piece of data, maybe from the disk, like reading some name or profile picture to show in a notification. So you actually need to do that disk access. So what can you do in this case? Now, broadcast receivers have this method called goAsync. It's basically a way to tell the broadcast receiver from the onReceive method that you need to do some longer running operation. And then you spin up a separate thread yourself, you do the operation, and then remember to call finish when you're done. If you don't do that, the system will still realize that you're blocking and might potentially kill your app. And remember, don't treat this as some kind of long-running service. This is not the case for broadcast receivers. And a reasonable time limit still applies. So you should literally just grab the things you need and the separate thread and finish as soon as possible. OK, let's talk a little bit about crashes. And it's really difficult to give general advice on how to avoid crashes in a setting like this, because every app will be different, every crash will be different. However, I can give you some advice that I think might be helpful. So, for years as an Android developer, I've seen my code or code from other people start very simple. And we release something, and then things start crashing on users' devices. And so we add all these safety measures, like checking for nulls everywhere, and checking for activity life cycles. And then if that fails, we just wrap everything in a try-catch and just hope that this problem doesn't hit too many users. But that's not the greatest solution, right? It doesn't actually solve the underlying problem. And that's why my first piece of advice to you is don't try to reinvent the wheel, and use readily available libraries that solve problems that you as developers face. Now, some of the most difficult parts of Android, we heard about it from developers, is handling life cycles. And that's why last year we released the architecture components, such as live data view model, for handling that. And also, we released room and paging components for loading data into your application, into your UI. This year at I/O, we're announcing 2 new components as part of the Android Jetpack initiative. This is navigation for handling all kinds of fragmented activity transitions and navigation problems, and the Work Manager for scheduling work in the background. But you don't have to use components provided by Google. There are a lot of great third-party libraries out there, and if you think they're useful to you in your application and they will solve your problems, feel free to use them as well. OK, the second thing I want to mention when talking about crashes is Kotlin. Now, also last year at I/O, we announced Kotlin as a first-class supported language for Android developers. And before I say anything more, let me just say that I know it's not a silver bullet. It will not solve all your crashes in your application. However, because of the null safety that's built right into the language, it can save you for some common classes of errors that you might otherwise hit with if you build your apps with just Java. And some of the other nice things about Kotlin are that it's highly interoperable with existing Java code. So you don't have to go all in and transform all your apps into Kotlin. You can start slowly adding it into your applications and see if it helps you. And actually, developers love Kotlin. And we are seeing a steady uptake in Kotlin usage in Android apps. And it's also easy and fun to learn. So I really encourage, if you haven't tried it yet, it's fully supported by us, and you're free to use it in your applications. And the last thing about crashes that I want to talk about is private and hidden APIs. Now, we offer an SDK to developers that's backed by documentation and basically public methods, public interfaces that you can use. But developers are finding ways to access methods in the Android framework that exist on devices that were never intended for you to use. And that's not because we don't like you as developers. We don't want you to give you nice things. It's just because that these APIs are not ready to be used. They're not guaranteed to exist. They might be implementation details on a certain device. We might even remove them on the next Android version, or a device manufacturer can go and customize Android to remove them as well. The thing is, you should never use private or hidden APIs in your apps. But in order to enforce that and to actually help you make your apps crash less in case these APIs change, we are introducing restrictions in Android P Developer Preview that means basically you have to stop using private and hidden APIs in your apps. And we did a similar thing in Android Nougat with the NDK, where we said you can no longer access libraries that exist on the system partition if they're not exposed by public NDK APIs. So please, if you can, migrate from private APIs to public APIs that are documented and guaranteed to work to make your apps safer. And let's talk a little bit about battery and stuck wake locks. So wake locks, it's an API that lets you basically keep the device from entering deep sleep, so from conserving the battery. And a stuck wake lock is when you use the API, and because of a bug or because you forgot, you acquire a wake lock, but you never release it. So it just keeps the CPU running, and it keeps draining the battery on your users' devices. So what's the best way to avoid having a stuck wake lock in your application? Well, you can't have one if you don't use wake locks. That's literally the simplest thing. And actually, in modern Android development, there's rarely a situation when you have to use a wake lock. If we think about activities, so whenever the user is actually using your app, and for some reason you want to keep the screen on, instead of setting a wake lock programmatically, just use a flag on the window that will tell the system to keep screen on. There's no way to leak it. For services, if you schedule them as jobs instead of having your custom free-running services, the job scheduler will hold the wake lock for you. And so again, you don't have to do that yourselves. Similarly, with Alarm Manager, if you use it to schedule an alarm in a broadcast receiver, there will be a wake lock held for you for the duration of on receive. So if you don't use wake locks, you don't even need that permission in your manifest, and you can't leak them. So that's great. But if you must use a wake lock, if you find a situation where you have to use it, remember to always choose a partial wake lock. All the other types of wake locks are deprecated on newer Android versions. And then always set a timeout value in wake lock acquire, so that in case you leak it, the system will clean up the wake lock for you after the timeout expires. Remember to give it a static descriptive tag without any counters or, even worse, like private sensitive information. That way, we can surface the name of the wake lock in the Android vitals for you for easier debugging. And then remember to always code defensively and assume things can go wrong, and use things like try and finally blocks to make sure that you release the wake lock as soon as you're done with it. And the last thing I want to talk about today is excessive wakeups. And I think the biggest cause for excessive wakeups is the use of this old API called Alarm Manager, and specifically the wake-up type of alarms. Now, let me give you the 3 R's of Alarm Manager. Remove calls to wake-up alarms if possible. Reduce the frequency if you have to use them for some reason. And if you can, replace your alarms with other APIs, such as Firebase Cloud Messaging, whenever the wake up has to happen for something that changed on your server, and you can send it as a push message. Or use one of the job scheduling APIs, such as the newly announced Work Manager, or even Job Scheduler or Sync Manager. And you know, with intelligent job scheduling, you get a lot of things for free, such as automatic backup and retry if your job fails for any reason. You get criteria-based scheduling, so you can only wake up the device when it has network or is charging, so that you don't actually run your code unnecessarily. You get DOS and standby compliance, and like I mentioned before, even automatic wake lock handling. And there's a whole session about background processing and a Work Manager API specifically, where you can learn more about this today. So I mentioned the Android profiler before, and I'm happy to say that today in Android Studio, we're also announcing the new Energy Profiler, so that you can debug any kinds of problems with wake locks if you use them in your app, and also see detailed information about alarms and jobs scheduled in your application. If you're interested to hear more about the profiler, please go to the session tomorrow. And with that, let me invite Fergus back on stage to talk to you about what more you can do to improve quality of your apps. Thanks.
Great. So we've covered a lot about what's available in Android Vitals in the Play console. I'm just quickly going to go through some of the other tools that you can be able to use to be able to improve the performance of your application. All of Android Vitals is based on data that's collected from users' devices. So these are users that are actually being affected by the issue itself. We would love for users not to actually be impacted by any of these issues at all. And so we'd encourage you to do more pre-launch testing of your application to find these issues before rolling it out to users. There's a session on this on Thursday at 9:30, and I encourage you to attend that one. Over the past couple of years, we've made radical improvements to the Android operating system to help users be able to get more out of their device in terms of performance and for the battery to last longer. There's major improvements with the latest version of Android, and that was covered in the keynote today. You can learn a lot more about that on Thursday at 11:30 in this session here. Wojtek covered a bunch of different tools within Android Studio to help you with improving your core vitals. But there's a bunch of other profilers and tools available to improve all the rest of your vitals. And so I encourage you to use Android Studio, even if you're using another IDE, for example, to build your game. Firebase offers many tools to help you be able to track the performance of your application. Crashlytics and Firebase performance monitoring being the most relevant ones for this talk. We encourage you to use those SDKs if you want to be able to do custom logging of your issues that you might be having with your application. Note there will be a difference in the data that's collected from the Firebase SDK versus what's collected through Android Vitals, which is from users who have opted in to sharing the data with Google and our partners at you. If you want to learn more about Firebase performance monitoring and Crashlytics, you can attend this talk at 11:30 tomorrow. We covered a lot in terms of what's available in Android Vitals in the Play console today, but there's a lot more to learn, and you can hear all about that on developers.android.com/vitals. Just to quickly recap, we started by covering why performance is vital overall, and hopefully you all agree that it is. That's why you're here today, so thank you. Then we covered what's new in Vitals, and I hope you take advantage of these new tools. Then we talked about how you can debug these core Vitals issues. And finally, what's available beyond Play Console Android Vitals. We'd love to hear your feedback on this talk. If you can be able to go to this URL and provide your feedback, we'd love to hear from you. If you have any questions for us, you can meet us from at 4 o'clock to 5 o'clock at this stand. It's on the other side of the lot. And we'll also be available at the Google Play Console Sandbox from 2 p.m. to 5 p.m. tomorrow to answer any of your questions. Thank you all very much for joining us here today. We hope that you'll make radical improvements to your application over the next year and that you'll get covered in our I/O talk next year. So best of luck to you all with improving your application. Thank you.